Hello and welcome to everyone out there in the Actual Tech Media audience. Thank you so much for joining us on the webinar today. The topic is common data management for containers and virtual machines in Red Hat OpenShift. I want to give a special thanks to our partners on the event today, Portworx by Pure Storage, Red Hat, and Intel. Now, before we get started, there's just a few things that you should know about the webinar today. First off, my name is David Davis of Actual Tech Media. I'll be serving as the host and moderator. As always, we want these events to be educational, and we encourage your questions here in the questions pane of the audience console. Many of you have already said hello and good afternoon, and we'd love to see that. We love to hear from our audience. But as the presentation goes along and the discussion, keep in mind that we need your technical questions for the live Q&A that we'll be doing at the end of the event. And we even have a best question prize to help further encourage maybe some of those questions. I'll talk about that more here in just a moment. I also want to call your attention there to the handouts tab. It's there that you'll find links to each of our three different sponsors on the event today, where you can learn more about their respective solutions. There's a link there to get started with Portworx, get started with Red Hat, and get started with Intel. So make sure you check those out. At the end of the webinar, it'll be my pleasure to announce the winner of our Amazon $250 gift card door prize. If you're watching this on demand or recorded, of course, that drawing would have already occurred. The prize terms and conditions can be found right there in the handouts tab of your audience console. And then, as I mentioned, we also have our best question prize. This is here to hopefully shake loose some questions. If you're not quite sure if you should ask a question, go ahead, ask away, and you'll be entered into the best question prize drawing. This is where you can win an additional Amazon $50 gift card. The prize winners will be selected and contacted after the event. And of course, you must still meet the Actual Tech Media prize terms and conditions. All right, with that housekeeping information out of the way, it is now time to introduce today's expert presenters. Welcome to Bhavin Shah, Senior Technical Marketing Manager at Pure Storage. Welcome to Michael St. John, Global Technical Alliance Executive at Red Hat, and Brian Cadell, Cloud Solutions Architect at Intel. It's great to have such a excellent veteran panel here on the event today. It's now time to kick off today's live presentation. I'll hand it off to you. Take it away.
Hello and welcome everyone. Good morning and good afternoon. Thank you for joining this webinar where we are going to talk about the common data management platform for containers and virtual machines for Red Hat OpenShift and how Intel and Portworx can help you build that common platform. Today's webinar will have three presenters or co-presenters. Let me start by doing some introductions. My name is Bhavin Shah, and I'm a Senior Technical Marketing Manager with the Portworx by Pure Storage or Cloud Native Business Unit at Pure Storage. I'll let Michael and Brian introduce themselves. Michael, why don't you start?
Sure. Hi, everybody. Good to see you here today. I'm Michael St. John, and I'm from Red Hat's Partner Ecosystem Organization.
Awesome. And I'm Brian Cadell. I'm a Cloud Solution Architect at Intel, and appreciate the time today.
Awesome. Thank you, Michael. Thank you, Brian, for joining me today. So let's look at the agenda, right? So we have a jam-packed 45 minutes session for you, where we'll start by discussing what does today's application landscape look like? How does the Kubernetes help with application modernization? Why are we thinking about, or why are organizations thinking about running virtual machines on Kubernetes? How do you actually run those virtual machines on Kubernetes? We do have a couple of interesting demos for you, and then we'll wrap up by how the three companies partnering together can empower your application modernization strategy. And then at the end, we'll open up for some Q&A. With that, let me hand it over to Michael to start talking about today's application landscape.
Yeah, thanks, Bhavin. So quickly, if we look at today's landscape, there are a lot of different platforms that are in use. You can't get around the fact that for most organizations anyway, there are applications built and running on bare metal deployments and data centers. There's applications in virtual machines. Some of those are running in private clouds like OpenStack, and certainly most organizations today also have applications that are running in public clouds or with managed service providers. And now we see more and more work being driven at the edge as well. So putting a lot more of that compute power closer to where the data is actually being created. Now, add to that there are a lot of different types of application architectures in use, from Java and .NET frameworks to cloud-native apps and microservices. There's AI workloads, machine learning modeling, as well as enhanced analytic workloads taking place alongside packaged applications. And developers are still using waterfall or agile methodologies in addition to adopting CI/CD pipelines and GitOps principles. In addition to skill gaps, changing security and governance concerns, different processes, tools, pipelines, this is all instituting a clear application development, operations, and modernization strategy that's very, very complex. So then how do organizations innovate with stability and scale within this hybrid mix of applications, processes, infrastructure? And moreover, how are developers and architecture and operations teams really able to work together to efficiently deliver software with speed, stability, and scale, and do so consistently across hybrid environments from bare metal servers to the public cloud and to the edge? Well, this is actually one of the great strengths of Kubernetes. It was actually developed in open source to orchestrate containers for application development in the cloud. But as it evolved more and more into a full-scale development environment for cloud-native applications, many other projects started being developed to enhance the capabilities of Kubernetes, so that now there are platform services, developer and application services, security, observability, data services, all of these things that complete the platform. And by pulling together all of the features and functionality built around Kubernetes, as we've done with Red Hat OpenShift, you have a more flexible environment that provides consistency across underlying infrastructure, workload, and tooling platforms that allow teams to efficiently build and run their software where it's best suited. Okay, so what does that mean for all of the applications that we have running in VM environments today? Well, there are certain challenges with traditional VMs, such as slow evolution. So, for example, it's difficult to quickly innovate to meet new business or competitive challenges in a VM type of environment, because you have to keep going back and asking for changes to the environment if you need to change that environment over time. It's very difficult to support growth. There's an inability for existing app solutions to scale to match business growth to new segments or to new geographies. And we see that there's an increase in costs. So this includes legacy costs of virtual machines, rising licensing costs as vendors strongly monetize older platforms. And, since it costs some money to maintain older versions as well, there's additional costs that are included in that. And then from a security and risk perspective, there's ever-changing risk and compliance requirements, complexity of securing applications across cloud footprints, just a lot of change and churn that we see with security and regulations these days. And then from a developer productivity standpoint, developers spend a lot of time fixing bugs, keeping the lights on, rather than really focusing on what they need to do and they do best, which is innovating and using newer cloud-native approaches to architecting applications. So how does Kubernetes help with all of these things? Well, first of all, by putting the system's resources in the hands of the developers, the analysts, the data scientists, whose job it is to innovate, they now have the ability to do so when they need to do so without filing tickets or waiting for infrastructure requests. And Kubernetes scales elastically. So by building event-driven architectures with tools like Apache Kafka, serverless capabilities like Knative, applications can even auto-scale to meet some of the requirements of the pipelines and workflows that are built into them. And then as a direct result of the elasticity, there's a reduction in costs associated with the utilization of underlying infrastructure. But also by automating the processes, there's an overall reduction in costs associated with managing resources. And there's a complete ecosystem of solutions that are built around security that's ever evolving, from securing access and content to securing the integrity of data and applications to providing availability and disaster recovery in the unfortunate event that your operations are breached anyway, But not to mention all of this, but the developer tools are consistently evolving and being updated as well. So since necessity is the mother of invention, and this is open source after all, you have a bunch of developers who are always searching for a better mousetrap. You can expect innovation and integration of developer tools being delivered with a consistent user experience, regardless of the underlying infrastructure. Okay, but how does all of that help us with applications that are already existing in a virtual machine? Well, virtualization as a concept has really evolved over the years from just being a way to segregate resources with a hypervisor and thus increasing your efficiency and utilization in a physical server environment to becoming more of a way of managing resources regardless of where they are, and then further putting those resources in the hands of those who need them, namely the developers or data analysts or data scientists who are innovating on behalf of the organization. So in the end, the value has really moved toward automation and cloud capabilities. And today we've extended that capability by providing virtual machines that run within Kubernetes infrastructure. So people can take advantage of all the tools and capabilities provided by a common DevSecOps platform, not only for containerized applications, but also for traditional applications that run in a virtual machine. Now, this virtualization capability is delivered by OpenShift Virtualization. This is based on the KubeVirt project. And really what the value is that it allows you to bring existing applications into a single platform and make use of all the same tools and operations teams that you would for all of your applications. Now, from an apps modernization perspective, it allows you to maintain existing apps, whether based on Windows or Linux, and then progressively build applications that integrate with those existing apps or decide when or even if it makes sense to modernize them. And so by bringing traditional applications and virtual machines into Kubernetes, you really get the best of both worlds. You're able to take advantage of a common DevSecOps platform with all of the tools needed for application modernization, but while maintaining the roles and responsibilities and not disrupting your business as usual. Then you can choose to modernize applications and processes on your own schedule based on your own priorities. So think of it this way. On day one, you can lift and shift existing applications. So you can move those existing applications to the Kubernetes platform within virtual machines. And then over time, you can refactor those applications. So for Windows apps, you can run .NET apps in Windows containers and support new Windows versions, and then refactor those applications to .NET Core over time. Likewise, for Java applications, you can individually replace application services as microservices over time, and then eventually incorporate event-driven architectures triggered by AI inferencing, and you can turn that into a feed for a continuous ML modeling loop so that you continuously improve your machine learning and the inferencing that takes place. And then when and if it makes sense, you can choose to re-architect your existing applications to cloud native and integrate more fully with the other cloud native applications and services that you're building. Or you could choose to, over time, retire and replace those apps by rebuilding or replacing the functionality with new applications and services. And then by doing this within the OpenShift platform, you introduce consistency and scale to your applications. So containerized apps and apps running in VMs are able to share app components and operations. Apps and VMs can take advantage of Kubernetes native functionality like GitOps and pipelines to codify and operationalize distributed architectures. And to that point, we have a public sector customer who's building an OpenShift Virt infrastructure to be deployed in 3 different security zones to run both mixed applications of pods and VMs, as well as traditional VM workloads. And they're using a GitOps approach to deploy and heavily automate virtual machine as code with Argo CD and Helm charts for configuration, and then using Tecton pipelines to automate their continuous integration and deployment of those apps. Now, this is an approach that we use extensively within our validated patterns initiatives, one of which we've actually built with Portworx, and several other initiatives that have been supported by labs and engineering efforts by Intel. So this is a great segue into what people are doing with these tools. Now, so then the one thing that needs to be considered with developing and deploying apps in Kubernetes is the statefulness of those applications. Because containers are ephemeral by nature, you need a persistent storage layer to maintain the state of your apps. And if you're deploying apps in both containers and VMs, that storage needs to be consistent across those environments. Now, beyond that, you also need additional Kubernetes data services available for business continuity to those apps. And so with that, I'm going to turn this over now to Bhavin to take us through some of the more technical details, and then he's going to show us a couple of demos as well. So,
awesome.
Bhavin, I'll turn that back to you.
Thank you so much, Michael, and thank you for giving that great introduction on the need and how or why people should be consolidating apps to get those benefits from having a unified DevSecOps stacks, following the GitOps principles for their applications, regardless of whether they're running on pods or on virtual machines. So as you already said, right, there is a unified way where you can run both your containerized applications and your virtual machine-based applications on an OpenShift cluster. Or if you just wanted to talk about Kubernetes on a Kubernetes cluster as well with the KubeVirt project. But most of my talk track will focus on how OpenShift provides OpenShift virtualization to make it easy for users to consume and run virtual machines on their OpenShift clusters. As you already said, you need that persistence layer or storage layer that helps you retain data for all your applications. And this is where Portworx Enterprise comes in. But in addition to the storage layer, you also need things like support for networking. So if you are an existing OpenShift user, or if you are an existing Kubernetes user, you are already familiar with the concept of CNI plugins or container network interface plugins. And you can use the same CNI plugins like a Cilium plugin with your virtual machine-based applications. You can also extend your layer 2 VLANs inside your OpenShift cluster so that when you are migrating your virtual machine-based apps and they were running on a specific VLAN, you can run that inside your OpenShift clusters using the Multest project as well. KubeVirt provides that layer of abstraction so that you can unlock the benefits of running VMs on OpenShift. And then monitoring and logging capabilities can still be provided by Prometheus and Grafana. So if you look at this, right, you're not changing any of the components of your OpenShift cluster. We are just enabling you to run your VM-based workloads on your OpenShift cluster as well. These VM objects inside Kubernetes are nothing but KVM native VMs that are wrapped inside a Kubernetes pod, which are managed and deployed by Kubernetes or by OpenShift. They are scheduled, deployed, and managed in the same way that any of your containers or any of your application pods will be. And then they support the same Kubernetes construct. So if you are familiar with how Kubernetes operators work and how Kubernetes custom resource definitions or CRDs work, VMs have their own CRD resource or custom resource by which you can define what a VM should look like. And we look at an example YAML file in the next slide. And because it supports the same Kubernetes construct, you can still leverage the same Kubernetes storage layer like a Portworx Enterprise and request for data volumes using the concept of persistent volume claims and persistent volumes. So with that, let's move to the next slide where we talk about what a VM definition actually looks like. So all KubeVirt VMs or all OpenShift virtualization VMs can be defined. Again, if you're using OpenShift virtualization, they can be defined through the OpenShift web console, or you can also define your VMs as part of a YAML file. As with anything in Kubernetes, even VMs are and can be defined by a YAML file. So as you can see, we have a custom resource called virtual machine object, and you can specify things like the name that you want to give that VM, the labels that you want to associate with it. You can specify the VM disks or data disks by creating a data volume and data volume template. And there you can specify things like the amount of storage you need for a specific disk. So with the capability that Portworx brings to the table for running VMs on OpenShift, you can have a different storage class or a different class of service for each virtual machine disk. So you might have a replication factor of 1 for your root disk, but for actual database, like for your actual data disk, you can have a replication factor of 2 or 3. So Portworx allows you to customize some of these things, and we look at all the different parameters that can be customized in the next few slides. But this is how you can define a VM object. Next, if you want to deploy a virtual machine, right, the steps still remain the same, just with an additional couple of components on your OpenShift or on your Kubernetes cluster. The user, if developers are deploying these VMs, they can still use their kubectl CLI utility and create or apply those YAML files that we saw in the previous slide. The request is submitted to the Kubernetes API server. And at this point, it talks to the virtualization controller or Virt controller and the Virt API, which are new components that are installed when you install the KubeVirt operator. And once the API server gets this request, it talks to the kubelet service that's running on individual OpenShift worker nodes or Kubernetes worker nodes. And then it creates a VM object on that node. So you have a Virt handler daemon set that's running on individual worker nodes where your VMs can actually run. So based on when the request comes in, the kubelet asks the Virt handler to create a new pod, which is basically a VM object on that worker node, and basically report back that the VM has been deployed. So this is how the flow works with like 3 new components, including the Virt controller, Virt handler, and Virt API. So this is what the changes that are needed and a higher level architectural overview of how it works. I know Michael spoke about the refactor, rehost, the different R's needed when you're thinking about moving your VMs inside or moving your traditional application inside OpenShift. But why should you run VMs on Kubernetes in the first place, and what benefits does it bring you, right? The first one being migrate. So you can take your existing virtual machines that are running on a vSphere environment or a Rev environment or an OpenStack environment, and you can bring all of these VMs inside your OpenShift cluster to use that unified tool set, unified management layer for deploying your containers and virtual machine based applications. So it allows you to move your virtual machines as is, perform a forklift operation or a lift and shift of your virtual machine based applications, bring them inside your OpenShift cluster, and then you can choose to modernize them at your own pace. So you don't have to worry about, oh, I have 100 applications. For me to fully utilize the benefit of containers and Kubernetes and OpenShift, I need to first spend a year and modernize all of my application, which is a really big lift. And then I can move things into OpenShift. That's not the case, right? Now, since we can run VMs on OpenShift, you can bring your virtual machines and then you can modernize when you want. You can bring all your applications as VMs, and then you can start component by component or application by application and slowly modernize while still getting all the benefits that OpenShift provides you. And then this basically enables to have a unified management layer or a unified platform for all of your applications. No longer do you need to maintain different hardware stacks or infrastructure stacks or different cloud environments just because you have applications running on a Kubernetes pod or on a virtual machine object on a vSphere environment. You can leverage the same infrastructure stack. You can consolidate not just the infrastructure resources, but you can also streamline the skills that you have inside your organization to run applications on OpenShift. So those are like the 3 main benefits that I feel running VMs on Kubernetes brings to the table. Talking about the modernization journey, right? We said like we don't have to modernize everything today. If you have a simple 3-tier application with a front-end component, a middleware component, and a backend database, you can bring those running as VMs on your OpenShift cluster. And as time goes on and as your organization is getting more skilled with the concept of containers and Kubernetes, they can start slowly modernizing your components. So you can start with one of these components. You can modernize your Apache component Instead of running it on virtual machine, you can run it as a pod, get familiar with how these things work. And then you can still keep your WebLogic component and your database component still running on OpenShift as virtual machines. Eventually, given more time, you can maybe modernize your WebLogic component, introduce JBoss, and run that as a container. And then finally, when you're ready to run state on Kubernetes, which usually lags by like 6 months, people want to be more familiar before they start bringing their persistent applications on Kubernetes or on OpenShift. Once you are confident, you can start modernizing your databases and start running those on top of your Kubernetes or on top of your OpenShift clusters as well. So it doesn't have to be a rip and replace or just rip off the bandage effort. It can be a gradual modernization effort where you move your VMs on OpenShift and then you gradually or incrementally modernize each of these stacks inside your application, each of these components inside your application stack. So let's talk about how Portworx can help, right? So Portworx Enterprise provides that market-leading #1 Kubernetes data platform that's available in the ecosystem today. And we provide the same set of benefits, including things like high availability and performance, business continuity with disaster recovery solutions, Kubernetes storage that is consistent regardless of whether you're running it on bare metal nodes, on virtual machines, or in the public cloud on cloud instances. We provide you the same set of capabilities. And Portworx Enterprise extends all of these capabilities to virtual machine objects running on Kubernetes or running on OpenShift as well. So let's talk about the things or the benefits that Portworx brings for OpenShift virtualization, or Portworx brings for the KubeVirt project. So as we said, it provides a common storage layer for containers and VMs. So no longer do you need to maintain 2 different infrastructure stacks. You can just use one single consistent layer when you're talking about running anything on OpenShift. So as we already spoke about, like if you're running on bare metal nodes, which is the case when you want to run VMs on Kubernetes or VMs on OpenShift, right? Portworx can be that software-defined or cloud-native storage layer where if you have physical devices inside your bare metal nodes, we can aggregate all of that and provide you with a unified storage pool that provides you with block, so read-write once, and file storage, read-write many storage. And we can give you the same capabilities regardless of whether you're running on bare metal nodes on-prem or metal-based instances in the public cloud, and give you the same consistency for running VMs on OpenShift. We also allow you to, we also enable live migration for virtual machines between different worker nodes. So I know if you're coming from a VMware background, you love the idea of being able to vMotion your virtual machines between different nodes in your ESXi cluster. Portworx plus OpenShift provides you the same capability and allows you to move your virtual machine objects from one OpenShift worker node to a different OpenShift worker node using a Portworx read-write many persistent volume. It enables high availability for virtual machines. What does this mean? If an OpenShift worker node that's hosting or running your virtual machine goes down, because of the way OpenShift and Portworx work together, so OpenShift will directly spin up or redeploy that virtual machine object on a different worker node. And with Portworx, since we have that in-cluster high availability and replication, all your data already exists on that second node in the same cluster. So as soon as OpenShift brings that VM object back online, it has access to all of its data, and your application can come back and be up and running quickly. It allows you to run containers and VMs side by side. Again, all of these capabilities that we're talking about today apply for both VMs and containers. And then 2 more things that I wanted to highlight today were Portworx provides you with the ability to build disaster recovery solutions for your applications. Again, Portworx has been doing this for a while for larger enterprises or financial services customers that want to run their applications on top of Kubernetes. But we are extending the same capabilities when it comes to virtual machines as well. You can build a synchronous disaster recovery solution, which gives you a RPO of 0, or basically 0 data loss, and an asynchronous disaster recovery solution for that cross-region architecture with an RPO of 15 minutes for your virtual machine-based application. So even if your primary site goes down, in a sync DR solution, you can recover your applications quickly on the secondary cluster with 0 data loss. And then an async disaster recovery solution, if your primary cluster goes down, you can bring your applications online quickly with an RPO of maximum of 15 minutes. So you can configure all of these things or all of these DR solutions for your virtual machines that are running on Kubernetes or on OpenShift. We have a demo for you today where we talk about these things. And then basically Portworx also allows you, let's say you modernized or you brought your virtual machines inside your OpenShift clusters today on-prem. And then in the future, you want to use like the Red Hat OpenShift service on AWS or the Azure Red Hat OpenShift service, ROSA and ARO respectively. And if you wanted to spin up or migrate your virtual machines to the cloud, Portworx can allow you to do those migration operations as well. So you're not tied down to a specific infrastructure stack. You can avoid any vendor lock-in and basically move your VMs wherever you want. So those are some of the key benefits that Portworx provides for OpenShift virtualization. Now let's talk about the storage class functionality, right? As we spoke about earlier, like Portworx allows administrators to completely customize how storage is being provisioned for your virtual machines. This includes customizing things like the replication factor. How many replicas do I want for a specific volume that my VM is using? What should be the file system type, XFS or ext4? Should this be a read-write once or a read-write many volume? Should this volume be encrypted? Portworx allows you to create affinity and anti-affinity rules so that you don't have VMs that belong to the same application running on a single node, because if that node goes down, you don't want all of your different components and all of your data to go down as well. Portworx can allows you to enforce those anti-affinity rules as well. We also allow you to set snapshot schedules as part of the storage class definition. So let's say you're creating your virtual machines, your 50 virtual machines are asking for persistent volumes from that same storage class. Instead of having to apply a snapshot policy to each persistent volume once they are deployed, you can define that requirement inside the storage class specification. So whenever a volume gets provisioned, it automatically inherits those parameters and creates those snapshot schedules. And these snapshots can be local inside the cluster, or you can also push it out to an S3 backend. This can be on-prem or on the public cloud. So that's how storage classes work. Let's talk about how Portworx provides that high availability, right? So if you're running virtual machines or pods on your OpenShift cluster, you have a PVC object which is used by these pods, by these VM objects, and which basically map to a volume inside the Portworx storage layer, which is a software-defined layer. And then let's say I have enabled a replication factor of 2. This means that I have my volumes running on the same node as my pods and VMs, but I have a replica that's running on different worker nodes, which is completely in sync with what the primary copy looks like. So if my node 2 or worker 2 goes down in this case, I can rest assured that as soon as OpenShift redeploys my pod and redeploys my virtual machine object, they get redeployed on the same worker node, which already has the replica of my original volume. So as soon as the volumes and the VMs and pods are now redeployed, they have access to all of their data and your application can come back online. Same is the case with live migration. So you have a virtual machine object with a read-write many persistent volume claim. Again, I think one thing to highlight is you need a read-write many persistent volume to enable live migration for your VMs running on OpenShift or on Kubernetes. Once you have that read-write many volume, if you wanted to move your virtual machine object from worker 2 to worker 3, you can just go to the OpenShift web console. Again, we look at this in a demo today. You can just select that I want to live migrate my VM to a different node in the cluster, and Portworx will move that persistent volume object and attach it to the replica on a different node as well. So this is how live migration works inside Portworx and OpenShift. If you talk about disaster recovery solutions, again, we have a demo of SyncDR, but let's start by talking about asynchronous disaster recovery solution. In this case, you have 2 different OpenShift clusters. You have 2 different Portworx clusters, your primary and your secondary cluster, where your applications are actively running on the primary side, and you have a DR relationship, which basically includes a few custom resources from Portworx, including a cluster pair object, a schedule policy for your RPO settings, and a migration schedule, which brings everything together. And at regular intervals that are defined in the schedule policy, we'll move not just your application data, so not just the PVC objects, but all the different application components, including things like service objects, deployment objects, config maps that you might have, and copy all of this and have it ready on the secondary side. So in case a disaster strikes and your primary node goes down, you just need to execute one single command per application or per namespace to bring your apps fully functional or back online on the secondary side. And since this is asynchronous, you'll have an RPO of 15 minutes. But let's say you wanted to an RPO of 0, right? A 0 data loss solution, which is what is needed for almost all mission critical applications or tier 1 application. You can use Portworx and create a stretched Portworx storage cluster across 2 OpenShift clusters. So this can be anywhere as long as your clusters are within that 10 millisecond round trip latency requirement. So it can be across different cities, across 2 different data centers in the same metro region. Once you have those created, you can your application can be running on your primary cluster, and you can be and Portworx will handle all the storage replication. Whenever your application writes new data, it copies it to the secondary site before it acknowledges the write back on the primary site. So if your primary cluster goes down, all of your data already exists. Again, you have to log into the secondary site, execute that one single command, and basically bring your applications back online with all of that data still there. So this is how Portworx does syncdr, and we'll look at this this feature in a demo today. And then finally, if you like all of these things, right, you might be thinking, how do I migrate VMs to OpenShift? And I know Michael covered some of this by talking about the migration toolkit for virtualization that Red Hat has. It's a simple to use UI. It can run on your OpenShift console cluster itself. It gives you a simple UI-based framework in your OpenShift web console where you can create mapping. So you can specify or create a source. This can be a vCenter instance. This can be a Rev instance or an OpenStack instance. And then you can define a target, which in our case will be the OpenShift cluster where we want to move these virtual machines, right? And then once you have created these providers, you can create the network mapping. So what network on my vSphere cluster? So which VNet is migrating over to which network on my OpenShift cluster. I can do a similar storage mapping for I can do a similar mapping for storage as well. So basically, if I'm running my VMs on a vSAN data store, how do I take that and bring it over to OpenShift and select the Portworx storage cluster on the OpenShift cluster? You can do all of these different mappings inside that migration UI, and then create a plan for migrating your VMs over. So instead of just talking about it in slides, let's just go and quickly look at a demo. So here we have an OpenShift cluster. Where you are, we have a vSphere cluster, which is running our test VM that we want to migrate over to a virtual machine. And let's just log into the VM and create a new file, which has a timestamp. So we're just doing an echo date in the test.log file. And as you can see, this was a demo that we recorded back in May for Red Hat Summit itself. And once the VM is ready, we'll look at how you can use the migration toolkit. So we have an OpenShift cluster with OpenShift virtualization already enabled. We have also enabled the migration toolkit for virtualization. Both of these are running as operators on my OpenShift cluster. So once I have these features enabled and installed, I also have Portworx Enterprise running on my OpenShift cluster. So when we migrate those VMs, it has a storage layer to persist that data. Now let's look at the virtualization tab, look at VMs. We don't have any VMs actively running right now because we haven't done the migration yet. Let's just confirm that by going to the VMs project or the VMs namespace. And again, you don't see any VMs actively running there. If we go to the migration tab, you can see that we can specify providers. And again, we define this in the OpenShift-mtv namespace. So you have the VMware cluster or vSphere cluster, the vCenter instance as my source. And I have my OpenShift virtualization OpenShift cluster as my target. I have created a network mapping where I'm mapping networks between my source cluster, which is a vSphere cluster, and an OpenShift cluster. So I can create that mapping. So anything that's running on VLAN 128 gets tagged as VLAN 128 on my OpenShift cluster as well. So I can still extend my layer 2 network across traditional virtualization and OpenShift virtualization. I can create a similar mapping for storage. So anything that's running on vSAN data store will use the pxcsi db-shared storage class to provision volumes for my virtual machine objects. And then once I have all of these mappings created, I can go ahead and create a plan for migration. So inside the plan, all I need to do is give it a name. So migration-test, we'll select our source provider, which is our TME vCenter as the provider. We can select a target provider, and then we can select a target namespace. In this case, we want to move the VMs into the VMs namespace that we have already created. Once that's done, I can select my hierarchy from a vSphere perspective. So I want to select the TME data center inside my vSphere cluster. I want to select the mig-test virtual machine for migration. Again, there are a couple of different migration methods available. One is a cold migration, one is a hot migration. We'll do the cold migration today for this demo. And then once I'm done, I can select the network mapping and storage mapping that we saw in the previous step. Once all of this is done, we can hit the next button and select the cold migration object. So let's click next. And again, We're doing cold migration. So as soon as you initiate this migration plan, it will shut down the virtual machine on your vCenter cluster. And then once the migration is done, it will automatically power on the virtual machine. So there will be some downtime. But again, if you wanted to do a migration, that's supported as well. Let's click next. And then if you wanted to run any Ansible runbooks as part of the migration, right? Maybe you wanted to make sure that once the migration is done, I update my load balancer endpoints to reflect the new endpoint for my virtual machine. You can include that as part of the migration plan as well. Once the plan is deployed, I can start the migration, and it basically starts the migration from vCenter onto OpenShift virtualization. It goes through a few steps where it first creates the volume. Then once the volume is completely ready, it then creates the VM object. As you can see, our virtual machine object is now ready to go using a Portworx backed storage class. It then converts my image to a KubeVirt image, which is basically a KVM native image. And then once my VM is completely migrated, we can navigate to the virtual machines tab. I can see my MIG test virtual machine is now running on my OpenShift cluster. It's running on worker-2 inside my OpenShift cluster. If we log in using the VNC console or the web console into the VM, we can log in through the same credentials. And now let's just test that the file that we created earlier with the timestamp still exists in this virtual machine instance. As you can see, it does. So next, let's look at a couple of different operations. Let's look at how easy it is to do live migration inside OpenShift inside my OpenShift cluster. So if I have a virtual machine that I want to move from, let's say, worker 2 to a different worker node in the OpenShift cluster, I can just navigate to that virtual machine tab, identify the VM, and click the kebab icon on the right. I used to call these hamburger icons, but now somebody corrected me. These are kebab icons. So I can just select migrate and migrate to a different node. This means it will be live migrated. So as you can see, it goes from running to migrating to running state. I didn't lose connection. My virtual machine didn't go down. This was a live migration operation. So instead of worker 2, it's now running on worker-0. I can reconnect to the VNC console. Again, even my session didn't expire because it was a live migration. I can do a cat test.log and see the same file exists, the same timestamp exists. And next, let's do a high availability demo where what happens. I want to show you what happens when an OpenShift worker goes down. How does the VM recover, and how long does it take for the VM to be fully running again? So instead of trying to pull out power cables and trying to simulate a node going down, what we'll do is we'll cordon off that worker node. So we are cordoning the worker-0, which is the node that's actively running the virtual machine. And then we'll identify the VM object and then delete the VM object. So when OpenShift tries to redeploy the VM again, it sees that the original node where it was running is no longer available because scheduling is disabled on that node. And then it chooses a different node in the cluster. Because of the way how Portworx works with OpenShift, it identifies that there was a replica of my persistent volume already existing on the worker-2 node in the cluster. Again, remember the live migration operation that we just did. So it basically redeploys that VM object on worker-2 because it already has a volume replica and brings my virtual machine back online with all of its data. So it takes a few seconds to delete the VM instance. So it stops the VM and then redeploys as soon as OpenShift sees that the desired state doesn't match the current state. It redeploys that VM object and brings the virtual machine back online on a different node in the cluster. So as you can see, it went from stopped to starting to running really quickly, and it moved back to the worker-2 because it had that volume replica ready to go. So that's a quick demo of how migration works inside OpenShift, how live migration works inside OpenShift virtualization, how high availability works inside OpenShift virtualization. And as a final test, we'll log into the VM again and then verify that our test.log file exists. So it does. So that was one quick demo of how Portworx and OpenShift allow you to run VMs or bring your VMs onto OpenShift clusters and give you the same features you expect on your virtualization stack. In the next demo, let's look at a second application. This is a mixed application, right? So you have your front-end components that are running as containers because you were able to modernize them, but your MongoDB backend database is still running on virtual machine objects. And instead of running the virtual machine object on a vSphere cluster, I'm running that same virtual machine object on my OpenShift cluster. So let's quickly look at this demo as well. So here we have a simple app. Again, it's a simple app where you can log in, create a new user, place a simple order. Both the user information and the order history gets stored in the backend MongoDB document database. There are two different collections for both of those things. Let's place a new order. I I'm a vegetarian, but I'm still ordering some smoked chicken. So let's look at our order history. We have 3 different orders that are stored in our backend MongoDB database. And let's log into our primary site, right? And look at the pods, the service objects, and all the different resources that are responsible for running my application inside OpenShift. As you can see, we have a few front-end pods that are responsible for the front-end UI of our application. And then we have a MongoDB VM running on this inside the same namespace called app-demo. We also have a persistent volume, which MongoDB VM uses to store data. And as you can see, it's a pxcsidb-dr storage class that is being created on Portworx. Now let's set up the disaster recovery solution. We are using a synchronous DR solution where my primary OpenShift cluster and my secondary OpenShift cluster are in the same metro region and can meet that 10 millisecond round trip latency. And in the migration schedule object, again, migration schedule is a custom resource from Portworx, which allows you to create a DR plan. So in the migration schedule object, I can define things like the cluster pair that I should use, whether I should start applications. Again, this is a DR, right? It's not a one-time migration. So I don't want my applications to come online on the secondary side as soon as the first migration is done. And then I can select the schedule policy for all the OpenShift or Kubernetes objects. Once we have the migration YAML, let's verify that nothing exists on a secondary side. So this is our secondary OpenShift cluster running the same version of OCP. It also has OpenShift virtualization enabled already with Portworx installed. As you can see, we don't have anything running in the app-demo namespace because we haven't initiated that DR plan. So let's go ahead and fix that. Let's go ahead and apply this YAML file to create our first migration instance. So a migration schedule basically creates individual migration objects at regular intervals. So I can do a storkctl get migration schedule in the app-demo namespace, and it shows me that okay, the migration is active. It was the first iteration of it was successful. It copied over 10 different Kubernetes or OpenShift resources from my primary to the secondary cluster. And then all the data was already replicated at the storage layer. So that's why you see the volumes of 0-0. Now, if we go to our secondary cluster and do a get all and a get PVC command. So let's do a OC get all in the app-demo namespace. You see, we already have the service objects, the route objects, the deployment object, the VM object, but the VM is stopped. The deployment replica count is set to 0 because again, we don't want to create that application inconsistency, right? Your application is still running actively on the primary side. In case of a disaster, we'll start running it on the secondary side. So let's go ahead and simulate a disaster event and restore our application or recover our application on the secondary cluster. All you need to do is just use this one single command called storkctl activate migration and specify the namespace. So -n app-demo. And at this point, since Portworx already had the metadata information about what VMs you had running, how many pods belong to that deployment object, we automatically scale up your deployment object and power on your virtual machine. So it takes a few seconds for everything to come back online. And we can verify that using the OC get all command. We can also look at the virtual machine object in the app-demo namespace. As you can see, our Mongo-VM is now running on the secondary cluster. My persistent volume object is now up and running as well, using the same storage class that was existing on the primary cluster. Once our application is failed over, instead of automating this, I'm manually updating the load balancer endpoint and the route object so that I can access my application again. Organizations do have a plan on how to handle networking changes or load balancer changes. Maybe they have a load balancer already running that can just route traffic to the new site. I'm just doing that manually for demo purposes. Once my route object has been updated, I can do a get all again and find out the new route endpoint. So let's do an OC get all in the app-demo namespace, fetch the new host / port combination for our route object. So let's do that, and I can skip forward a bit. So basically, we copy and paste this in a browser session. As you can see, we are going to the new endpoint. We can log in using our same demo user. So demo@portworx.com with a super secure password. And we should be able to see all the different orders that we placed when the application was running on the primary side. I can continue using this application. We can place more orders. And then whenever my primary cluster is back online, Portworx can also help you perform a fail back operation. That's not a demo that we're doing today, but that's fully supported with Portworx as well. So after both of these demos, let me quickly go back to the slides and hand it over to Brian, where he can talk about how Intel is working with Portworx and Red Hat to enable all of these interesting use cases. So Brian, over to you.
Thank you, Bhavan. Real quick, Red Hat and Intel have been collaborating and building and executing the last 25 years to create a software-defined and silicon-enhanced to help our customers with their digital transformation journey. As we all know, across edge to cloud, which includes compute, network, and storage, everything is software-defined. That's where we've been working to make the most seamless customer deployments. And you also know today's workloads are no longer just general purpose, but tailored towards addressing specific workload requirements and needs. Intel and Red Hat and Portworx are providing the building blocks for this digital transformation. From edge to cloud, hybrid to multi-cloud, across bare metal, virtual cloud, and edge deployments, which provides the flexibility for our customers. Red Hat and Intel and Portworx are allow you to deploy your containerized workloads when and where you need them with the agility, reliability, and flexibility to move them anytime, anywhere. A quick snapshot just to give you a glimpse as to the flexibility that OpenShift provides with obviously the help of Intel and Portworx being there, but obviously they exist in all the major CSPs, OEMs, along with Red Hat's capability around AI. A quick glimpse around the 4th gen Sapphire Rapids or 4th gen Intel Scalable Xeon processor, 1 to 8 socket capable, increased core count from the previous gen Ice Lake, and introducing the most built-in accelerators in the market today to address real customers' needs and workloads. Inclusion around introduction of DDR5, PCIe 5, and CXL. And then a quick snapshot as to maximizing the effectiveness of every core. So Intel's been addressing workload optimization by building acceleration into our products in 2 ways. Integrated ISA, increasing application performance by taking advantage of instructions on the core, like AVX 512, 5G ISA, and AMX, and integrated IP, or adding integration IP accelerators on the chip, increasing effectiveness of cores by enabling offloading of common mode tasks via seamlessly integration acceleration engines like DSA, QAT, DLB, and DSA. We introduced seamless integration acceleration engines which help free up cores with more general purpose compute tasks, increasing overall workload performance and reducing overall service jitter. So double clicking on the 4th gen Intel Scalable processor. So what we do is we learn from our customers, and Intel is targeting real world workloads to provide better performance and efficiency. Many of these features are enabled through an Intel One API tools and Intel optimized AI frameworks. Each accelerator functions in a different way to deliver value, but they also operate to provide benefit to a specific workload or category of workloads shown here. Some accelerators such as QAT provide benefits to many workloads like security, network, HPC, and storage. Purpose-built features on Intel's Xeon processors designed to improve performance, cost savings, and sustainability for targeted workloads. So I want to highlight one quick thing around OpenShift and Intel's collaboration around their OpenShift offering around AI. For example, Intel's AI toolkit helps accelerate model deployment. Think of TensorFlow and Pandas. Intel AI toolkits offer extensions that greatly accelerate model deployment, and OpenVINO optimizes inferencing to make better use of available systems. So if you have an inferencing model running on a hardware at the edge, for example, that may not have the best or the greatest processor or accelerators, OpenVINO can help to optimize performance accuracy ratio. In other words, typically model accuracy comes at a price, and that performance. OpenVINO helps you to optimize performance while ensuring that you infer accuracy, your inference accuracy is acceptable for a given service level agreement. In addition to a robust Intel Xeon processor, we are now introducing Habana Gaudi, deep learning acceleration to Red Hat's OpenShift data science offering. Habana is available in AWS Rosa as an EC2 DL1 instance today. Bhavin, I want to turn this back over to you for closing remarks.
Thank you so much, Brian. And again, I would like to thank Brian and Michael both for joining me today. We covered a lot of content. We did a lot of demos. So now if you wanted to follow up on any of those things, right, you can scan the QR code that we have on the screen to find more information of how Portworx, Red Hat, and Intel are working together and how we can help you run your containers and virtual machines on OpenShift. With that, let me open it up for some question and answers, and we'll be here to answer those. So guys on the webinar, feel free to put some questions in the chat and we can pick them up right now.
All right, great presentation. Thank you to all of our excellent presenters. And thank you to our audience, of course, for all the great questions coming in. It's now time to kick off the Q&A session here. If you have a question that's on your mind, now's the time to drop it in the questions box. Don't forget about our best question prize as well. I'll go ahead and just kick it off with this first question here that came in from Michael in the audience. He's asking, do the primary and secondary cluster have to exactly mirror each other resource-wise? Bhavin, what's your take on that?
Yeah, so again, that's a great question, right? And the one word answer is no. It depends on how you architect your DR solution. If you're just using your primary cluster as that active site to run all your applications, that can have a larger footprint, and your secondary site can be small. Secondary cluster can be smaller because again, you're not actively running anything. But you just need some auto scaling rules in place so that in case of a disaster event, when you're trying to restore your applications, your secondary cluster can actually run all of those applications and you don't hit resource limits. So with some planning, you can definitely achieve that, and that's not a requirement from Portworx or Red Hat. Like you can have a mismatch cluster in terms of resource configuration.
Excellent. Yeah, thanks for answering that one. Great question, Michael. Let's see, here's another good question. This one from Peter in the audience. He's asking, is it possible to manage all or a majority of the OpenShift platform through Ansible automation? And I think Michael already answered that a little bit with a link in the electronic Q&A. But Michael, maybe you want to add to that or just clarify for the audience who maybe didn't see that?
Sure, yeah. So, absolutely, you can use Ansible automation platform with OpenShift. Clearly in setting up and configuring your OpenShift clusters, but also in managing the applications within Kubernetes. Also, a lot of folks can automate some of their IT services as well, ticketing systems and things like that. So if you have services that are running within your Kubernetes environment, you can automate that as well. I did put a couple of links in the Q&A as well that point to a couple of the GitOps patterns that we've actually created. One is an Ansible Edge GitOps pattern, which uses OpenShift virtualization, very pertinent to the call today, as well as another one that goes back to our pattern that we developed with specifically with Portworx. And that uses Ansible automation for part of the configuration as well, so you can see it actually running.
Awesome. Yeah, that would be cool to see. Thank you for those links. I encourage everyone to check those out. They're in the questions pane of the audience console. Let's see, here's another good question. They're asking, do I need to use OpenShift UI to perform live migration operations? Bhavin, how does that work?
Yeah, so we can definitely use the OpenShift UI that we saw in the demo, right? But since this is Kubernetes, this is OpenShift, and everybody loves YAML, you can also have a YAML file for live migrations of VMs. So if your developers don't want to access the UI at any point, they can definitely do that.
Very nice. Very nice. Let's see, here's another good one. Paul's asking, he says, aside from Intel AI, does OpenShift offer other AI integrations for IoT or edge computing?
So certainly if you take a look at the OpenShift data science platform, there's a lot of different integrations. It's really an MLOps platform, so it's really meant for your data scientists to be able to have all the tools that they need
to share and actively work together. So you'll see NVIDIA in there as well as Intel, things like Starburst, Starburst Enterprise Trino, to kind of like do some of your data discovery and things like that. There's a lot of different pieces of that ML Ops platform, but then that particular platform is part of a greater umbrella called OpenShift AI, and that will be having a much more robust ecosystem of tools. We are actively working on bringing in things like IBM Watson into that platform as well.
Excellent, excellent. All right. Well, it looks like we're running out of time here in our webinar. We could chat the rest of the day, I think, about all the great questions and these topics here around common data management for containers and virtual machines with Red Hat, OpenShift, Portworx, and Intel. This has been a really great session. I want to give a big thank you to all of our expert presenters and sponsors, Bob and Michael and Brian. It's been great having you on. Thank you so much.
Thank you, David.
Yeah, thank you.
All right, and thank you to the audience as well. Of course, check out the handouts tab. There's links there to get started with Portworx, Red Hat, and Intel as well. And with that, I will now announce the winner of our Amazon $250 gift card here on the live event. This is going out to Harold Neiman from Wisconsin. Congratulations. And we'll be reviewing all the great questions that came in after the event and contacting our best question prize winner as well. Make sure that you visit Red Hat, Intel, and Portworx by Pure Storage for more information on the event today. And have a great day. We'll see you next time. Bye-bye.